This video, we're going to be talking about visualization, what it is, and why we visualize data. So to start with, data visualization is explained as the process of transforming abstract data into interactive graphical representations for the purpose of exploration, confirmation, and/or presentation. I've just created a little timeline here just to illustrate the changes in data visualization over time. So 6000 BC, the Konya town map from Turkey has been dated to be 6200 BC and is considered to be one of the earliest visualizations ever discovered. The map indicates the town and where people lived, as well as other key landmarks. So this is what it looks like. It's very primitive and simple, but do remember this is 6,200 years ago. In the 1600s to 1700s, Age of Enlightenment, 16th century marks a time where information was readily being recorded on paper. Leonardo da Vinci's drawing of the human anatomy is one example of visual representation of information. Highly recommend you looking at it. It's super interesting. We also have Galileo, where he was able to depict different phases of the moon in 1616 by visualizing and displaying the various shadows across the moon to his audience. Very cool as well. And finally, we have William Curtis providing botanical sketches and illustrations of various plants in 1746 to 1799. 1800s, as technologies and ideas developed further through the later stages of the Enlightenment period, engineers like William Playfair began developing different visualizations such as pie charts and bar charts, which are still used today to represent data. And you have to look at the greatest ever infographic in the number 5 video, 2014. This was very, very cool. This was illustrating the Napoleon War that happened from France to Russia. Very cool. Definitely got to watch that video. In 1850 to 1900s, by the mid-1800s, London-based physician and pioneering epidemiologist John Snow created a visualization which went on to change the world in terms of the way we think about identifying the spread of diseases. Highly recommend this video as well. This is probably the priority video. 1850s map, how it changed how we fight outbreaks. Very, very cool. Before, they kind of thought it was just this random thing that you caught just by luck. But once you watch this video, John Snow, very smart man, was able to pinpoint the cause of the cholera outbreak by mapping out the city and the various deaths that occurred. It's very, very cool. And then finally today, visualization and indeed data visualization has continued to evolve and change how we see and reflect around the world today. It also has the ability to help us communicate and to represent situations and problems that some people are facing. For example, The Guardian uses visualization to demonstrate the mass shootings in the US. This is also a very cool one. It's sad, but it kind of puts into perspective, every day there's a mass shooting going on with human bodies in different sort of stick figures to represent different deaths going on. So those are some cool visualizations. Why we visualize data is probably even more important. So one reason why visualization is useful to us is that we have limitations in our attention and memory resources. Therefore, we cannot hold all of the data in our head nor make sense of it. Instead, we use what we call external cognition, which essentially allows replacing the thinking in our head with the thinking in the outside world. Computers and calculators are common examples of external cognition. This is a really cool sort of test. Can you tell which data source has the highest mean, variance, correlation, and linear regression? I'll give you a moment just to think about it. Also pause the video and I will explain it in 3, 2, 1. Well, actually, this is a classic dataset known as Anscombe's quartet. The trick question here is that none of the graphs have the highest value. All 4 datasets are specifically engineered to have nearly identical summary statistics. So for all 4 graphs, the mean is exactly 9. For all graphs, the mean of the y values is approximately 7.5. Variance of x is 11 and y is 4.1 across all 4. Correlation is y and x is exactly 0.816 for all 4, and the linear regression shares for all 4 shares this formula. And as you can see, even though there's different data points, all these 4 metrics sort of are very, very identical. It's really cool. So the more you get exposed to different ways of representing information, the broader your conceptual toolkit becomes. In any analytical or technical field, limiting yourself to a single framework restricts your vision. Expanding your visual literacy allows you to map out a much wider known space, giving you the foundational vocabulary needed to interpret complex data and uncover patterns that others might miss entirely. This is not just for data visualization, but for life in general. You don't know what you don't know. So if you know more things, you have more possible solutions. Therefore, you should be able to pick a more specific, better solution for a problem. So this visualization demonstrates the space of all possible solutions to a problem. If you only know a tiny subset of options, as shown in the bad scenario on the right, your entire problem-solving process is structurally choked. When your initial awareness is heavily restricted, your consideration space and proposal space contract proportionally. This forces you to pick a selected solution from a shallow, low-quality pool, resulting in poor solution represented by the square, while completely missing out on optimal approaches represented by the X's that lie just outside your narrow worldview. Whereas if you're aware of a whole array of possible solutions, then you're much more likely to choose the best procedure. As illustrated in the good scenario, a vast and deeply understood known space allows you to cast a wide net across the entire problem landscape. This abundance of data lets you filter down through a diverse consideration space and a highly targeted proposal space, drastically maximizing your chances of landing on a genuinely optimal high-value selected solution. Ultimately, making the right choice relies entirely on having a broad enough horizon to see in the first place. So you can take a moment to just pause and just sort of understand what's going on in this visualization. Well, moving on, these are the different types of data visualizations you might not have heard of before, but are very useful. Parallel coordinates, chord diagram, tree maps, calendar view, you've definitely used before, a choropleth, stream graph, bubble charts. There's so many. We're so used to just using bar graphs and pie charts, but there's heaps. And once you know of different ways of representing data, you're able to choose the option that enables you to be more precise and explain your findings cohesively to an audience. Ultimately, the core purpose of creating data visualizations is to transform raw, complex data into meaningful insights that better inform people, shift perspectives, and empower them to make better evidence-based decisions. A historic testament to this is Dr. John Snow's map of the 1854 London cholera outbreak, as we touched on before. By plotting cholera deaths against the locations of public water pumps, this visual revealed a deadly cluster centered directly around the Broad Street pump. This geographic visualization successfully challenged the medical status quo, convinced authorities to remove the pump handle, and laid the foundation for modern data-driven epidemiology. So we're going to let John Snow's legacy remind us that a single well-crafted visualization has the power to shatter false assumptions, save lives, and change the course of history. When you design your charts, don't just display numbers, reveal the hidden truths that inspire action and drive meaningful change. And this is the map. The video goes into much greater detail. It's very cool. Perfect. So now we're going to be touching on HTML, CSS demos, JavaScript demos, and SVG demos. And I'll explain why in just a moment. So right now we're going to have a look at this placeholder text that we've written up before writing the meat and bones of the HTML and CSS file. The first line is doc type HTML, and what it does is that this is the document type declaration. It tells the web browser that this page is written in HTML5, the current standard, ensuring the browser renders the page correctly. You might be wondering as well why it's highlighted, and in HTML, the character combination of the less than symbol followed by the exclamation mark, followed by the greater than symbol at the end of the tag, is highlighted in blue because the code editor's syntax highlighting recognizes it as a special declaration rather than a standard HTML element. Moving on to the next line, HTML language en. This is the opening tag for the entire HTML document. The lang en attribute specifies that the primary language of the page content is English, which helps search engines and screen readers. The head section is the opening tag for the head section. This area contains behind the scenes information, metadata, script styles that the browser needs, but it does not show up in the actual web page. So meta character set UTF-8, what it does, it sets the character encoding to UTF-8. This ensures your browser can properly display almost any text character, symbol, or emoji from around the world without turning them into weird broken symbols. The next line is the meta name equals description and content equals to data visualization exercise 1. So what it does is it's a description of your page. Search engines like Google often use this text to show a summary snippet in search results. The next line for meta name equals keywords, content, HTML, and CSS. It provides a list of keywords relevant to the page. Modern search engines mostly ignore this now, but it's still used for internal organization or older systems. The next line is meta name equals to author, and content is Rohan. So credits the creator of the page, in this case myself. Then we have the title. It defines the title of the web page. This is what appears on the browser tab and when you bookmark the page. The next line is the script src equals to https, etc. This imports an external JavaScript library. Specifically, it loads D3 JavaScript version 5, a powerful library used for creating data visualizations like graphs and charts using HTML, SVG, and CSS. And then we have the /head, which closes the head section. The next part that we're going to look at is the page body. So we have the body, and what it does is it's the opening tag for the body section. Everything placed between body and the closed /body at the very end will actually be visible to the user on the screen. And what it does is, for the last HTML as well, it closes the entire HTML document, signaling the end of the file. So now I'm going to put in the body section and we'll go through what it means. I've now inserted the code inside of the body section. So pretty much we have H1, H2, H3, which stands for heading 1, heading 2, heading 3. And as you can tell, the headings get smaller respectively. We also have P, which stands for paragraph, which is just a place to create paragraphs for your text. HR stands for horizontal rule, which creates this line break. We have OL, which stands for ordered list, and we have LI, which stands for list item. So OL creates the overall container for the list and tells the browser to automatically number the items sequentially. We have strong, which bolds the words. We also have EM further down. As you can see, common routines. EM stands for emphasis. So we have the images, or just the one image of the cat, sorry. So you do image src, source cat.jpg, with the ALT stands for alternative text. So why altered text is crucial is for accessibility screen readers. So visually impaired users use software called screen readers to read web pages aloud. When the software hits an image, it reads the alt text so the user knows what the image represents. And it just says a domestic cat resting comfortably indoors during lockdown with 400. And we have pretty much the only other thing is the copy. So if you write it like this, it has the copy symbol at the bottom. And we have the hyperlink. href stands for hypertext reference. Pretty simple. So we also have the target, which is used inside of an anchor tag, which I'll explain in a second. The target equals to underscore blank opens the link in a new tab or new window. If you did target equals to underscore self, it opens the link in the same tab or frame where it was clicked. So the A here, for example, stands for anchor. It is the tag used to create a hyperlink, which connects your web page to another page, a file, an email address, or a specific spot on the same page. So the A tag cannot work alone. It requires an attribute to tell where to point, which we talked about before, href, along with the text the user actually clicks on. That's pretty much it for the HTML part. Pretty simple. Now I'm going to add some CSS styles to it, and I'll be back in a second. Cool. Now we've added the CSS code, and as you can see on the right-hand side, a few things have changed. The colors of the different headings, some bits are italicized, the footer has changed a little bit, but essentially all that we've done is we changed the color, the font family, the sizes, different weightings, so bold, normal, etc., and the margins as well from bottom to top. A few things I want to touch on. So we put style ahead of the body section and inside of the heading section, or the head section rather, because if you put your CSS styling above the body, which is what we're doing, the browser reads all the design rules first. By the time it starts reading the text and images inside the body, it already knows exactly what color, font, and size everything should be. The page loads perfectly, styled all at once, whereas if you put style at the bottom, the browser reads the HTML first and immediately displays them using standard boring black and white text, for example. And then a split second later, it reaches the bottom, finds the CSS, and suddenly snaps the colors and layouts into place, which creates an ugly, jarring visual glitch known as a flash of unstyled content, FOUC. So what else that we did was I added this figure section. And essentially, figure acts as the parent box that groups the image and caption together. And fig caption renders the text directly underneath the image. I just did that just to show you that there's another sort of style element you could do. And then in the CSS, we prevented the caption from extending past the image like this by displaying it in the table. And the width as 1 pixel forces the figure element to shrink wrap rather tightly around the image. And then we just italicized the fig caption. At the bottom, it looks kind of fancy, but essentially all we've done is we've just created it with a monospace font family, really small font size, and then we've added these borders, paddings, and margins. So there's nothing too fancy there going on. This is just basic CSS happening right now. But the last thing I wanted to touch on was the difference between border, padding, and margin. So if I can grab my Miro board, I'll drag it here. Essentially, what happens is, in web design, every single element on a web page is treated as a rectangular box. So if I grab the drawing tool, so I've got the drawing tool up, and what I'll do is I'll create this rectangular box to sort of illustrate the difference between padding, borders, and margins. So let's say there's some text in here. So essentially, the padding is the space between the text and the border. Let's use blue. This space here. So when you increase the padding, it increases this distance. this is the border. So if you increase the border, what happens is that it gets thicker, essentially. The border will get thicker if you increase the border. And the margin, so let's imagine that there's another sort of rectangular box representing another element. This space here is the margin. So if you increase the margin, it increases the distance between two elements. And that's essentially the difference between padding, borders, and margins. And that's everything that I wanted to touch on for HTML and CSS in this brief sort of explanation, leading into more complex stuff for data visualization. We're now going to be looking at a JavaScript demo. So if HTML is the skeleton structure and CSS is the skin/clothing styling, then JavaScript is the brain and muscles. JavaScript is a programming language that makes web pages interactive. Without JavaScript, a web page is completely static. Clicking a button does absolutely nothing. JavaScript listens for user actions like clicks, hovers, or typing, and instantly changes the HTML and CSS on the fly without making the user reload the browser. So we're just going to go through a demonstration now. So I've written out a new HTML file, including CSS and JavaScript. Now what we're going to do is I'm just going to explain line by line what is going on. But first, I'll just walk you through the different features. So you can toggle, when you hover, it kind of changes the lighting. You also have the different figure captions and the images change. I'm just going to quickly show you. So normally in the future, what we're going to do is we're going to put the data into D3, which will generate visualizations. But for now, we'll just use Excel and screenshot it. So I'll just show you how we did that quickly. Yep, what we did was you highlight the data sources and you go to insert charts, and then I thought that a clustered column would best represent this data that I'm trying to represent. So I chose that, but there's other versions as well. It's a very simple way of creating visualizations. Now going to go into a line by line breakdown. So as you can see, the underneath head, the meta characteristics are still the same. So going into CSS, we have the font family, which sets a modern clean system font fallback chain instead of the default browser font. The reason why there's so many is a question that I had. And the reason that that's the case is because the long string of names is what developer calls a font stack. So this specific combination is known as the system font stack. Instead of making the user download a heavy custom web font file over the internet, it tells the browser to use whatever beautiful modern font is already built into their operating system. So we have Apple and Blink Mac system font. They tell iPhones, iPads, MacBooks to use Apple's clean high resolution system. And then you have SEGOE user interface targets Windows devices. You have Roboto, which targets Chrome, Helvetica and Arial, which are older universal fallback fonts. And then you also have sans serif, the ultimate safety net. Absolutely everything else fails. It tells the browser just use whatever default font you have, as long as it doesn't have little decorative feet serifs on the letter. So that's the font family explanation. We also have the max width and margin. This handles the structure, locks the content width to maximum of 800 pixels, and centers the entire column horizontally on the screen with a 40 pixel space at the top and bottom. Padding prevents the text from hitting the absolute edges of the screen on the small mobile layouts. You have background color, sets the subtle off-white background color seen around the edges of the main card container, which is this section here. You can see it's a little bit more off-white than the main section. And then you also have the color, which sets a soft dark gray for the body text, which is easier on the eyes than the pure pitch black. We have so that was for the page layout and the body. Now we have the headers and the white card container. H1, and then you have color, tints, the primary title, pet ownership in Australia, clean deep slate blue. You have the text align center, which centers the title text on the page. You have margin bottom 30 pixel, pushes the white container card down by 30 pixels to give the heading room to breathe. For the visualization container, we have the background with all Fs, which creates a sharp, clean white card background that houses the your buttons and the chart. As you can see, buttons, chart. You have the border radius, box shadow, drops a very soft, faint shadow underneath the card to make it look like it's lightly floating off the gray background page. Just around here, you have the text align center, button layout and characteristics. So you have controls. Then you have the margin, so it creates a space directly beneath the row of buttons so they don't sit flush against the Excel chart image. Then we have the buttons. You have the background colors, borders, none, padding, font weight makes the text bold and prominent. Margins, cursor pointer forces the user's mouse pointer to change into a hand icon when hovering, indicating that it is clickable. So the cursor becomes a pointer. Transition, crucial animation property. It tells the browser to smoothly blend colors and sizing over fractions of a second when the user interacts with the button rather than switching instantly. Yeah, like just like this. The hover pseudo class, when the user rolls the cursor over a button, it suddenly shifts to a deeper, darker shade of indigo to indicate it's responsive. Active is a pseudo class that the moment the mouse is actively clicked down on the button, it shrinks down slightly to 98% scale, mimicking a physical button being physically pushed down. This is, see how like pressing it shrinks down a bit. The next button, active, is a combo class. So this styles the button that represents the currently active view as controlled by the JavaScript. In the screenshot, compare 2019 to 2021 button has this state, turning it into a deep navy black with an internal shadow that makes it appear visibly toggled or pressed in. So the chart image and the figure text, we have margin and padding. We have chart image, max width, height, auto, border, 1 pixel solid, puts a faint gray border frame around the screenshot. For the fig caption, we have the margin, the font style, and the color. So that is the CSS, which is all at the very beginning inside of style. Now, and that's also inside of head. Now in the body section, we have the HTML. So the first one, H1, pet ownership in Australia, it defines the primary structural header of the page. It tells the browser that this text is the most important title in the web document. You have the structural wrapper, which is the next bit. Div class equals visualization container. All other elements are inside here. So what it does is this acts as a box or wrapper to group your entire interactive infographic together. In the final visual, this tag is what allows the CSS to draw that clean white card with rounded corners and a soft drop shadow around all your content. Which is this bit here. We have the controls, the buttons, button compare, button 2021. So the div class controls groups the buttons into their own layout row so that they sit cleanly together above the chart. You have the tags, creates the actual interactive elements you see at the top of the card, which is the button tag. You have the ID attributes, ID button 2021, acts as a unique label so your JavaScript knows exactly which button is being referenced. You have one click, which is the trigger. It tells the browser the moment a user clicks this button, run the show data function in JavaScript. We also have the figure. So this is a semantic HTML tag used to mark up self-contained content, like the diagrams, photos, or coding listing. It acts as an intentional structural frame for your chart area. And then we also touched on what alt meant in earlier, so that's all good. Big caption, pretty standard. Now this next part under script is the JavaScript. Also, I guess you'll touch on the dynamic image as well before we get to the JavaScript. So the image, ID, chart image, pet ownership, bar showing, pet ownership, penetration, etc. So the ID chart image gives the image element a name tag so JavaScript can find it and dynamically change the chart view when a button is clicked. Pet ownership 2021 specifies the default image path to load when the web page first opens. Alt provides a textual description of what data is in the chart. It fulfills your rubric's requirements, so it's appropriate for people that are visually impaired. The dynamic caption, again, when you click between the buttons, the caption changes as well. So this pairs directly with the figure tag to attach a label to your graphic. The ID chart caption allows JavaScript to seamlessly rewrite the caption text, switching the description from rates in 2021 to between 2019 and 2021, the exact same moment the chart image swaps. And now finally, we're going to go into the JavaScript. So we have the first function, show data view type. This defines a function, a reusable block of code named show data. It takes a piece of incoming information called a parameter, which we've named view type. When the user clicks a button in the HTML, it triggers this function and passes either the text 2021 or compare into it. So now we have the finding the HTML elements, the grab phase. So this bit here, what's happening is that before JavaScript can change anything, it has to find it. So this searches a HTML file for elements with specific ID. We store references to those elements in variables so we can easily manipulate them in the next step. We grab the image, the text caption beneath the image, and both buttons. Then we have the condition tree. So if view type is 2021, it checks did the user click the 2021 button. If it does, view type equals the text string 2021. If yes, it runs the next 3 blocks of code inside the curly braces, which is pet ownership PNG and the bar chart showing ownership penetration. What's happening is the in-chart image.src targets the source file of the HTML image tag and instantly swaps it to the 2021 only screenshot. The second line updates the accessibility alt description so the screen readers know the chart content has changed. The second bit rewrites the caption text. So text content rather reads inside the fig caption element and rewrites its plain text to say rates in 2021. Then the final bit, third bit, is tweaking the button appearance. So what's happening is that when you click the class list.addActive applies the dark navy active CSS style to the 2021 button that looks visibly pressed down. And .class list.removeActive strips the styling away from the comparison button so it returns to its normal state. The alternative path is else if, compare, and pretty much it just does the same thing but for the compare button. And that's it. That's the entire code to generate this infographic on the left. And just a bit of theory on JavaScript. The final demo we're going to look at is the SVG demo. So unlike normal web images like PNGs or JPEGs, which are made of thousands of tiny square pixels that get blurry and blocky when you zoom in, an SVG is completely made of mathematical code. It uses coordinate geometries to draw lines, circles, and polygons perfectly. Because it is just numbers and math, you can zoom in infinitely, and the image remains perfectly crisp and sharp. In HTML, you declare an SVG canvas by creating an SVG container tag, and then you code individual geometric shapes directly inside of it. SVG stands for Scalable Vector Graphics. So now I'm going to touch on the key benefits of SVGs, which include infinite scalability. Because SVGs are drawn using mathematical coordinates rather than fixed grid of pixels, they are entirely resolution independent. The benefit is that you can scale an SVG up to the size of a billboard or shrink it down to a tiny icon and it will remain perfectly crisp and sharp. It never becomes blurry, pixelated, or jagged, regardless of the screen's pixel density. You also have dynamic interaction and animation. Since SVG elements sit directly inside the web page's document object model, DOM, they behave exactly like normal HTML elements. The benefit is that you can use JavaScript to listen for user events like clicking a bar on a chart to update a caption and dynamically changing the shape attributes on the fly. You can also use CSS to add hover effects, transitions, and complex animations directly to individual pieces of the graphic. Tiny file size and performance. So for geometric shapes, logos, icons, and charts, SVG file sizes are drastically smaller than their PNG or JPEG equivalents. So the benefit is that a chart containing dozens of bars requires only a few lines of text code to describe rather than thousands of pixels of color data. Smaller files mean web pages load significantly faster, improving performance and user experience. It's also perfect for data visualization. So SVG is the foundational canvas for advanced web-based data visualization libraries like D3, JavaScript. The benefit is that instead of drawing static images, libraries like D3 take data arrays and use JavaScript to dynamically calculate coordinates, generating custom charts, maps, and graphs that adapt perfectly as the underlying data shifts. Also, search engine optimization and accessibility. Because SVGs are written entirely in XML text, search engines like Google can read, crawl, and index the text inside the graphic. So the benefit is that you can add structural elements like title and description tags directly inside the SVG code, making your graphics natively accessible to screen readers for visually impaired users without relying solely on standard external alt attributes. Real-world examples include web logos and brand icons, dynamic dashboards and web charts, interactive maps, and user interface weather animations. So as you can see on the right, we have the shapes that we've drawn with SVG, and I'm just going to explain the code that we've written. So the metadata and the description keywords, etc., is all the same. Title is drawing shapes with SVG, and then inside the body we have the heading drawing shapes with SVG here. Now, as we said, we have SVG, and the width 600, height 150 properties act exactly like an artist's canvas boundary. Setting a custom background color ensures the shapes contrast sharply against it. Yep, it's the background canvas. We have the circle, and we have the rectangle and the ellipse shapes. So color customization as well. The template passes the criteria by using a blend of solid hex codes, pure SCC system keywords. like this. That's STC keywords, where the trailing 0.6 value sets an explicit 60% transparency level on the green block. Border controls, the stroke parameter changes the line border color, while stroke width alters how thick or thin those outlines appear. So I also just want to touch on X, Y, and CX, CY. So X and Y attributes define the top left corner of a shape and is used for shapes like rectangles. X is the horizontal distance from the left edge, and Y is the vertical distance from the top edge. You also have CX, CY, which is the center points, which is used for circles, as well as ellipses. But you also have RX and RY, and that stands for radius X, radius Y. And because an ellipse is an oval, it doesn't have a single uniform radius like a perfect circle, so it needs two separate radiuses to define its shape. So you have a horizontal, which is the distance from the center point CX to the left or right outer edge, and the vertical radius, which is the distance from the center point CY to the top or bottom outer edge. So that's it for SVG and this video on the fundamentals of data visualization. We'll be deep diving into more complex things later, but hopefully you enjoyed this video. Thank you.